expenditure minimization problem. Given the utility function, which is a calculus 1, equals u bar, the requirements, the utility requirement we got to achieve. Okay, and given the first order condition, Lagrange 1, which would be P1 minus lambda, and U1, what would U1 be? U1 would be alpha Q1 alpha minus 1 Q2 to the power of beta. And Lagrange 2 would be P2 beta Q1 to the power of alpha Q2 to the power of beta minus 1 equals 0. And now we have P1 over P2 equals alpha over beta, and this will be Q2 over Q1. Okay? But this time, the expenditure doesn't just apply to the first order condition. The first order condition would be U bar minus Q1 alpha Q2 beta equals 0. So we have to do something differently. Q1 equals alpha P2 Q2 over beta P1. Or put Q2 here. So we replace this. This result comes from the last two first order conditions, and replace this to the first order condition. We have U bar equals Q1, which is alpha over beta P2 over P1 Q2 to the power of alpha and Q2 to the power of beta, and alpha beta P2 P1 alpha Q2 to the power of alpha plus beta. Is that right? And the solution of Q2 star would be U bar multiplied by the inverse of this term, and we may make it by something like this. Beta alpha P1 P2 to the power of alpha U bar to the power of 1 over alpha plus beta. This would be the solution of Q2 star. Okay? Because U bar equals this, and we just rearrange the equation so that we may have Q2 star. And you will see Q2 star is a function of what? Of P1, P2, and U bar. It's a function, Q2 star is a function of P1, P2, U bar. And what about Q1 star? Q1 star is Q2 multiplied by this term. So Q2 multiplied by this term. It will be what? Alpha P2 beta P1 to the power of beta U bar alpha plus beta, 1 over alpha plus beta. Because this, when you want to put this term into the square parenthesis, you have to make it the power of alpha plus beta. And this term is actually the inverse of this term. So minus alpha, the power would be minus alpha. And so we have the beta here. And what about the optimal expenditure? It would be P1 Q1 star plus P2 Q2 star. Okay, you see Q1, Q2 star are both functions of U bar, P1, P2, and this would be P1 multiplied by this. Okay, so it's P1 and P2. This will be here, and this will be here. Okay. So the optimal expenditure would be also a function of P1, P2, and U bar. P1, P2, and U bar. And this function, expenditure, is the minimum expenditure necessary to achieve a specified utility, which is U bar, utility level, for a given set of prices, P1, P2. And you may verify this using the same procedure in the previous slide. You have this. The marginal expenditure caused by an unit increase of P1 would be Q1 star, and this would be Q2 star. What does it mean? Which means if you want to reach the same utility level as required, and now you are facing an increase of P1 by 1 unit, and the extra expenditure you got to pay would be Q1 star, which is your consumption level. So the more you consume, the impact of the price increase will be higher. So you got to pay more. Okay? So you may easily verify this. Just follow this procedure. And if you don't want to do this, it's fine. It's fine. I just want to understand the intuition behind the problem. So in the final exam, I wouldn't do something asking you this. I just want you know that to make you understand. But I may still give you some problem like this. You got to solve the expenditure minimization problem. But I wouldn't require you to verify the result. Okay, any question here? We're going to finish chapter 3 and proceed to chapter 4. No further questions? Okay. Chapter 4. So you see the title of chapter 4 is demand. You may think, oh, demand, I know demand since I was in junior high school, and also in senior high school, and in my fresh year in the university. Oh, I have already learned demand. But now, I give you some different things about demand. We want to know how we derive demand, how the demand function is derived. Okay? So, if you do not have questions about this, I will erase them. Okay? When the term demand come up to your mind, what would you have in your mind? Okay, substitution effect, income effect, and anything else? What? Hicks, Slosky. Okay. Substitution effect, income effects, Hicks, Slosky. Okay, most people don't know Hicks and Slosky because we didn't introduce this before, right? And anything else? Oh, Chevrolet. Chevrolet is actually something we should talk in the graduate school level. Anything else? The law of demand actually, the Q, right? The law of demand should be the basic one, the most basic one. And can we derive the demand function using the indifference curve approach? Let's try. Q1 and Q2. Once again. Q1, Q2, Q1. Okay, now we have a budget line here. Okay? And we have another budget line here. So we say this would be I1 and I2. What do you think the difference between I1 and I2? What changed? What has been changed in I1 and I2? If we have P1, P2, and Y, you just pick one among these three. Which one has been changed so that I1 will be changed to I2, P1, right? Because the vertical intercept would be y over p2, right? And this would be y over p1. And if you see the rotation from I1 to I2, it must be caused by the increase of, the decrease, the drop of P1. Okay? If P1 drops, then our budget constraint would be, the budget line will rotate outward. So, together with an indifference curve, and if this is the initial optimal solution, the equilibrium, and now with the new budget line, we have another optimal solution, right? Another equilibrium. So we change the level of P1, and we have a different solution here. So if this is P1 and Q1, so which P1? P1 on I1 or P1 on I2 is higher? The level of P1 on I1 or on I2 is higher. I1, right? So this Q1 corresponds to a higher P1, and this Q1 corresponds to a lower P1. Is that right? So you connect these 2 points, you have the demand. Is that clear? All right, so this is the budget line. So from a very high P1 to a very low P1, you will have various equilibrium points, right? Given this constraint line, given this budget line, you will have a equilibrium, something like here, right? And you will have another equilibrium, 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 equilibrium. Is that right? So you will correspond to different level of Q1 you consume. You may have something like this. Alright? So the highest P1, lower, 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 lower. So you will have the highest P1, different P1, and you will correspond to different Q1, right? So this Q1 comes from here, 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 here. All right? So with the indifference curve, indifference curve, indifference curve, indifference curve, when the price of commodity 1, P1, changes from high to low, you will correspond to different equilibrium level or equilibrium quantity demanded, right? So we may derive the demand function by this. Okay? Now, pick from P1, P2, and Y. Pick one among these three. So which one can make the budget line change from here to here to here? Which one? Y. Right? Income. So you have more income so that your budget set becomes larger and larger and larger, right? And suppose this is the case. What about P1? Do you think P1 has been changed or not? In this case, only Y changes, right? P1 and P2 remain constant, remain unchanged. So given an unchanged P1, so we may have this, this, and this. So you will see the demand function will change from D1, D2 to D3. So the effect of a change from the Y, from the variable Y, the income, if you have higher income, then your demand function will shift outward in this case, right? In this case, more money, more consumption, which is a normal good, right? Higher income, more consumption. So it's a normal good. So the normal good, right? And let me introduce to you something. We just make a line, make a curve connecting all equilibrium points. And because the change is due to the price, due to P1, so we call this curve as a PCC, price consumption curve, yeah, price consumption curve, PCC, price consumption curve. And the reason why we call this curve as a price consumption curve, this curve connects all equilibrium points, okay? And because the change comes from the change in price, so it's price consumption curve. And this would be ICC, income consumption curve. Income consumption curve, because the change comes from the change in income. So the change, the rotation from here to here is due to the drop of price 1. And the change from here to here is due to the increase in income. And here, the rotation from here to here is due to what? Due to the drop of P2, right? When P2 decreases, so your budget sets become larger and larger, right? And the corresponding, say, this D1, D2, and D3. It depends. So from D1 to D2, from here to here, after the change of P2, after P2 decreases, we see the consumption of Q1, the quantity demanded of Q1, become less, which means they are substitutes. Okay? Good 2 becomes cheaper, so I cut the consumption of Q1 because I buy more Q2. So within this range, the relationship between Q1 and Q2 are substitutes. However, from here to here, it becomes complement because P2 keeps dropping, but the quantity demanded of Q1 becomes larger. So in this case, it would become complements. So sometimes they are substitutes, sometimes they are complements. You say, oh, it's weird. How come we may have the relationship between two commodities is also substitutes and also complements? The key point is here. Next week, I will introduce something we call the income effect. I will introduce income effect. So we need to distinguish substitution effect from income effect so that you may understand why sometimes you will see, because P2, the price of commodity 2 decreases, but sometimes the quantity demanded for Q1 is cut, sometimes is raised. So you may think it's weird why we may have this kind of result. But once you understand the difference between substitution effect and income effect, you will perfectly understand why. Okay? And which will be the topic next week. But here, I want you to know 3 things. Actually, 2 things. The first thing is that the demand curve can be derived by the indifference curve approach, by the indifference budget curve approach. Okay? So we have subjective preferences, our tastes, and the objective constraint. So with the subject part and the objective part, we may have the equilibrium. So we capture the equilibrium points using P1, Q1, so we may derive the demand curve. And because the change of the budget line comes from the change in P1, in the price of good 1. And the change in income, you will see the demand curve shift, because at this time, P1 is constant.